Dear students, welcome to my channel. As you can see, today I am starting with number Roman 5 of 5 of exercise 8.4 of chapter 8, that is class 10 trigonometry. In my last two videos, I have already solved number Roman 5 of 5. So if you are watching this video first time, you first go through the links given in the description box for my class 1 and class 2, that is the last two videos. In that videos you will find the solution up to Roman 4 of 5. So also some strategies are discussed in the previous videos how to solve this type of problem. So first you go through the videos. Now let's start with Roman 5. Here see, the question is proved that cos a minus sin a plus 1 by cos a plus sin a minus 1 equal to cosec a plus cot a. So there are three techniques, from LHS to RHS or from RHS to LHS, or you can separately calculate LHS and RHS and show that both the values are equal, that is LHS equal to RHS. So which technique in this problem we can apply? See, the RHS part is very simple one, only sum of two terms, but in the LHS it is in a rational form, that is P by Q form, and there are three terms in each part. So by quickly you have to apply the technique, which method will be very helpful. See the process here. First, what I am doing, see the value of RHS as it is a very simple one, cosec a plus cot a. So what is cosec a? It is 1 by sin a plus cot a means cos a by sin a. Take the LCM. LCM is sin a 1 plus cos a. So this is the value of RHS and very easily you can get it. Now try to find the same value from LHS. So I am starting with LHS. Now we are calculating the value of LHS. Now see here, cos a, all the terms are same, cos sin 1, cos sin 1. Only difference is of the signs. Here it is minus plus, here it is plus minus. So how this can be arranged? See, you take a negative sign common from the last two terms, so it will be sin a minus 1. Here plus is there, so no sign change will be there. Now see, sin a minus 1, sin a minus 1 same, so the form is a minus b by a plus b. In this case, multiply numerator and denominator by conjugate of the denominator, which is done in class 9 in the certs. Same process, multiply by the conjugate of the denominator, cos a minus sin a minus 1. In the numerator it will be cos a minus sin a minus 1 whole square, because multiplying this term, this is same as this one, so it will be whole square. Now in the denominator part, a plus b into a minus b, so it will be a square, means cos square a, minus b square, b square means sin a minus 1 whole square. Here break the whole square, it is a, it is b, so a square minus 2ab. A is what? A is cos a into b is sin a minus 1 plus b means sin a minus 1 whole square. A minus b whole square. Now in the next step we have to simplify. See, it is cos square a minus, here also break this a minus b whole square, a square minus 2ab, it will be this plus b square means 1, here it is cos square a minus 2 multiply by this 2 cos a, so it will be minus 2 cos a sin a, minus 2 cos a sin a, minus minus plus 2 cos a plus here see, it is a minus b whole square, a square minus 2 sin a as done in the numerator part, 2b plus 1. Now some simplification. See here, it is cos square a plus sin square a. Cos square a plus sin square a is in the first step you just arrange the terms, cos square a plus sin square a plus 1, the last term, minus 2 cos a sin a plus 2 cos a minus 2 sin a. Here what can we do? Do one thing. This cos square a, we write 1 minus sin square a minus sin square a. Multiply this by this negative sign, so it will be plus 2 sin a plus minus 1. So what is the benefit of writing this cos square a 1 minus sin square a? See, this 1 minus 1 will be cancelled. In the next step, here now no technique is there, just now simplify. The technique is the starting part. So this plus 1 minus 1 cancel, 2 sin a minus sin square a minus sin square a, it will be 2 sin square a. Here sin square a plus sin square a 1 plus 1 minus, see here minus, you write this term. In the next term I will give the reason why it is written first, plus 2 cos a minus 2 cos a sin a. Now in the denominator part, 2 sin a common, it is 1 minus sin a. Here 2, 1 plus 1 2, in this term I am changing, it is 2. So from this term, see, 2 common, 1 minus sin a, plus here 2 cos a common, 1 minus sin a. So the reason behind writing this term by this way, it is the fact to factorize the numerator term. So after doing some practice of these types of problems, you will automatically understand the reason behind arranging the terms like this. Now see that here 1 minus sin a is common, 1 minus sin a common, 2 plus 2 cos a, this is simple factorization, 2 sin a into 1 minus sin a, 1 minus sin a, 1 minus sin a cancelled. From these two terms, 2 common, so it is 1 plus cos a by 2 sin a, 2 cancelled. So what remains? 1 plus cos a by sin a. See, the value of RHS and value of LHS both are same, therefore we can write LHS equal to RHS, hence proved. More 3 ways or 2 ways you can prove this problem, this solution you can done in 3 different ways also. First one is by changing the LHS into cosecant chord, that is by Roman 6 of 5. This is the question, prove that root under 1 plus sin a by 1 minus sin a equal to sec a plus tan a. Here also you can start from RHS as well as from LHS also, or you may calculate both separately. This is calculate LHS and calculate RHS, show that both the values are same. Here I am showing the proof from LHS part. LHS is what? 1 plus sin a by 1 minus sin a. Now see these two terms as in the previous one. Here these two terms are same but they are conjugate, that is one is 1 plus, that is a plus b, another one is a minus b. The same technique as applied in the previous one. Conjugate, if two terms, similar terms two terms are there but they are conjugate of each other, then try to rationalize the denominator, that is multiply both numerator and denominator by the conjugate term of the denominator. So what is it? It is 1 minus sin a. What is conjugate of this? It is 1 plus sin a. So in the numerator part it will be 1 plus sin a into 1 plus sin a, multiplying by this term. Now see the next step, it is a minus b, a plus b. What is a minus b into a plus b? It is a square minus b square. Here it will be 1 plus sin a whole square. Now see what is 1 minus sin square a? 1 plus sin a whole square. 1 square means 1. So 1 minus sin square a is cos square a. Now see one thing here, root under x square is what? It is x. So what will be this one? Root under 1 plus sin a whole square? It will be 1 plus sin a. Root under 1 minus cos square a, it will be cos a. That's all. The problem is finished. Now you just split the term 1 plus cos a plus sin a by cos a. 1 plus cos a is sec a plus sin a by cos a is tan a. This is exactly same as RHS, hence proved. If you start from RHS, so the steps will be almost the same, but you start from this and you will have to end here. So from RHS to LHS you also can prove this one. In another way, you start from LHS, calculate LHS, start from RHS, calculate RHS, and show that both the values are same. In that way you can also prove this one. Okay, so now see number 7. Prove that sin theta minus 2 sin cube theta by 2 cos cube theta minus cos theta equal to tan theta. As you can see here, RHS is a very simple expression that is consisting of only one term tan theta. So it will be better we start with LHS, as in the LHS there are more terms, more larger expression. So let us start with LHS. Sin theta minus 2 sin cube theta by 2 cos cube theta minus cos theta. See here, what simplification? The easy simplification can be done first. See in the numerator part, first term is sin theta, second term is 2 sin cube theta. So sin theta can be taken common. After taking sin theta, 1 minus 2 sin cos square, 2 sin square theta remains. Here cos square theta common, cos theta common. What remains? 2 cos square theta minus 1. Now what can we do? See here, this part sin theta by cos theta is tan theta, that is we are getting RHS. It means that this part will cancel anyway. Now how to prove this one? As here the term is sin square, here it is cos square. As we clear that these two term will cancel each other, so we convert any one of them into other. What we are doing? Let us change sin square theta into cos square theta. What is the formula? Sin square theta equal to 1 minus cos square theta. Okay, cos theta here, no change in the denominator. Now since sin theta by cos theta, here what it will be? Multiply by this minus 2, 1 minus 2 minus plus 2 cos square theta by whatever is there you write. See the next step, sin theta by cos theta into minus 2 plus 1 plus 2 cos square theta. So it will be 2 cos square theta minus 1, 2 cos square theta minus 1. Cancelled. What remains? Sin theta by cos theta equal to tan theta equal to RHS. So it is clear. The main thing is 3 identities plus their deductions. These formula are very useful for this type of problems. So all the formulas, all the identities, all the relations you have to memorize always. Okay, now let us see the next one. For number 8, I am not solving this one, giving hints. This one is very easy. For question number 8, you see the question, just break the whole squares, then simplify. Automatically you will get RHS. Start from LHS to RHS. I am not solving this one. This one is your homework. This one is very easy. Now we are solving Roman 9. Question number 9, see the question, cosec a minus sin a into sec a minus cos a equal to 1 by tan a plus cot a. As you can see, again RHS is very simple one comparatively of the LHS part. In the LHS part there are 2 terms as in the multiplication form. If you multiply this, there will be 4 terms, and in the LHS only 2 terms are there. So let us first calculate RHS. See the RHS part. What is RHS? 1 by tan a plus cot a. What simplification we can do here? Convert this into sin cos, and cos a is cot a is cos a by sin a. So what is the LCM? LCM is cos a into sin a. After LCM we are getting sin a is there, so sin a into sin a, sin square a plus cos square a. Now see, this is an identity, cos sin square a plus cos square a. Sin square a plus cos square a is 1, so it will be 1 by cos a sin a, that is cos a sin a. So this is the value of RHS. Now we try to simplify LHS and try to show that LHS is also equal to cos a sin a. Let us see this. Start from LHS. LHS equal to cosec a minus sin a into sec a minus cos a. Now as up to this we have RHS equal to cos a sin a, that is terms are in cos and sin. So here see that sin is there, cos is there, this one sec, this one cosec. It is better we convert cosec and sec into sin cos. So what is cosec? Cosec is 1 by sin minus sin a. Here it is 1 by cos minus cos a. What is the LCM? Take the LCM here. Nothing. Another thing you can do, you can multiply the terms. Then you will also get this result. It will be easier. Take the LCM for the first term and take the LCM for the second term. Sin a, so it will be 1 minus sin a into sin a sin square a into, here the LCM is cos a, 1 minus cos square a. See here it is sin a into cos a. Now what is 1 minus sin square a? Again the use of first identity, sin square a plus cos square a equal to 1. So what will be 1 minus sin square a? It will be cos square a into 1 minus cos square a will be sin square a. Now one term cancelled, here one cos cancelled. What remains? Cos a into sin a. So both the values are same, therefore we can write LHS is equal to RHS. Hope this one is also clear. Now let us see the next one. Here see there are 3 parts, so we can't use LHS or RHS because there are 3 parts. As up to 9 there are, in all the sums there are 2 parts, that is prove this equal to this. Here 3 terms, so we have to prove that this one equal to this equal to this, or you may show that the first part equal to third part, second part equal to third part, that is this equal to this equal to this. See this technique here. Let us start with this part. We are writing first part equal to, what is the first part? It is tan square a by 1 plus tan square a by 1 plus cot square a. Now see, here tan and cot are there. There is a relation between tan and cot. Tan a equal to cot a, or cot a equal to tan a equal to 1 by cot a, or cot a equal to 1 by tan a. So I am doing here converting cot. Cot is 1 by 10, so it will be, as it is cot square, it will be tan square a. Now see 1 plus tan square a, here we can take the LCM, tan square a, it will be tan square a plus 1. Now see this term same, they are cancelled, so what remains? 1 by tan square means this equal to tan square a. See first part equal to tan square a, equation, give it equation 1. Now see this second part. In the next part we will try to show that second part is also equal to tan square a. So now start with writing second part. What is second part? It is 1 minus tan a by 1 minus cot a whole square. Again here tan is there, cot is there, we use the relation between tan and cot. 1 minus tan a by 1 minus 1 by tan a whole square. Here take the LCM, tan a, it will be tan a minus 1, 1 minus tan a whole square. Here is a problem. See one term is 1 minus tan a and here it is tan a minus 1. So what we can do? It is clear, if we can cancel these two terms, then we are getting tan square a. Now for this negative sign problem, you first split the whole square. It will be 1 minus tan a whole square. Here it will be tan a minus 1 whole square by tan square a. Next, here in the next term, in the next step, this tan square a is here, as it is 1 by, it will be in the numerator part into, see here in within bracket take a negative sign common, so it will be 10a minus 1 whole square by 10a minus 1 whole square. As you can see, you know this fact, minus 1 square equal to what? It is plus 1. So as a square is there, so no negative effect of this sign will be there. In the first term it is 10 square. Now as minus square is plus, so it will be 10a minus 1 whole square, and in the denominator it is 10a minus 1 whole square. Now see, these two terms are same. Now we can cancel the term equal to 10 square a. This is equation 2. Another way you can do, the first part equal to write this, then convert tan and cot both into sin and cos. That is, here sin square x by cos square s, here cos square by sin square. Here for the second part you start from here, then write tan equal to sin by cos, cos equal to cos by sin, take the LCM, you will be getting the same result. So in equation 1 first part equal to 10 square a, in equation 2 second part equal to 10 square a, that is first part equal to second part equal to 10 square a. Therefore you write here like this, from equation 1 and 2 we have, or we get, these are the techniques. Hope all the sums are clear. Nothing but uses of the identities of the formulas of complementary identities, sine, cos, reciprocal relation. All these are very useful for this type of problems of exercise 8.4. and if you go through R.S. Agarwal or R.D. Sharma, there will be same type problem but lots of sums are there. I will recommend to practice some extra sums from R.S. or R.D. Sharma, but the techniques are like this. All of the sums are based on the identities and all the relations. Hope this exercise is clear. Next we will start heights and distance, that is application of trigonometrical part. Hope this video was helpful. Thank you.